Hello, my name is Craig Gallen. Today I'm going to give you an overview of how OpenNMS can be used to monitor a website, and in this example I'm going to be using the public website from the United States Patent and Trademark Office. I'm going to start off by showing you features that are in the current version of OpenNMS. I'm using OpenNMS 31, although these features have been available for some time, so previous versions of OpenNMS probably have the same features that I'm going to be showing you. I'll also show you some work that has been done with Selenium. OpenNMS historically had a Selenium poller, but this has been depreciated. However, I wanted to give you an overview of what that poller did, and with a view to seeing whether it should be reinstated into the capabilities that OpenNMS has. So let me start by looking at the USPTO Patent and Trademark Office website. So as you can see, it's quite a complex site, and I'm going to look at two things on this site. First of all, I'm going to look at how can we test whether the trademark electronic search is working, and then I'm going to look at the patent public search. So actually I'm going to start with the patent public search. So if we went onto the site and went to patent public search, we would come to this particular page. And I'm going to do a basic search, so let's have a look at it. Now, the problem with the basic search is that it basically uses JavaScript in this page. So although it's not a simple post request, it's actually posting JSON. So in this search, I'm going to search for a particular patent, and what I want to do is see what's going on when that happens. So I'm going to look with the Firefox tools, web developer tools, and I'm going to look at the network and see what's going on. So I'm sending a search, and you can see that a post has been sent, and if we look down we can see there's actually been a response. So I'm looking for a particular patent. This is a patent from Nant Health, and I'm looking for this response to that search. So in this post you can see that I have sent a request, and the request is a JSON request. And the response, and the key thing about this is the number that's been put into the request, and that's been generated through JavaScript on the page. And obviously the response has come back, and the key thing about the response is that I'm getting back this patent number. So if I wanted to do an ongoing search or an ongoing test of this site, and I wanted to do repeated searches to make sure the site was working, what I would need to do is send the request to pub UBS USPTO gov. I need to send this JSON request, and I need to see the response coming back. So how do we do that within OpenNMS? Well, if I go to my example page, this OpenNMS Integrations Play website monitoring is where I've done all of this work. So this work's available for you to use and play with. And you can see that in this case I'm using the HTTP post monitor, which is a capability within OpenNMS that allows you to post requests to a website and look for the responses. And I'm also using metadata within OpenNMS, which is a relatively new feature, but what it allows us to do is to set up multiple post monitors with different data or going to different sites. So it makes it much easier to reuse a particular poller rather than having to write a separate poller for every site. So we can see that if I jump down to OpenNMS and actually go to OpenNMS, what we have in OpenNMS is 3 minions running, and we have on those minions a number of different services running. So I'm going to look at Web04, which is actually running on the default site, this means this is actually running on OpenNMS itself. But if I looked at the minions, Web Service 05, in this case it's running on Minion Europe 1, and the other one's running on another minion. So these are polling from different locations. Minion Europe 1 is obviously in Europe. Minion default is obviously where this OpenNMS is running itself. And we can see under the services that are running
we have a USPT post and USPTO trade search and web DNS temp search. So this web DNS I'll come on to in a minute, but let's look at the USPTO post one to start with. And we can see that this particular example is going after this interface on the node, and it is sending this particular request as part of the post. Now that request is essentially the same request as we saw in this raw. If I go to raw, you can see that's the actual JSON here. I've picked up that JSON. I've replaced the quotes with ampersands, web escaping. But basically, if we go back then to the service, you can see that essentially that's what it looks like. Okay, so it's making this request and it's doing it on a 5-minute interval, and it's getting the result back. What's it doing with the result? Well, the result it's looking for is the number that we had talked about, and so if you can see here, this is the response text US B2. Okay, so I'm sending out this request and I'm expecting that response back, which corresponds to what's happening in the actual website itself. That's the response back, and this is the request that's been sent out, and I'm doing that in a 5-minute interval. Okay, so that's the first example. Now I'll just show you how that is done within OpenNMS. So within this example, and I've got all of the screenshots here, you can see that what I've actually done is I'm posting this request, obviously with this number, and I'm getting the response back, which includes this particular text, which is the text that I want. Okay. Now the polar configuration is in 2 parts. First of all, in polar configuration.xml, we set up the actual web post monitor. But the key thing about the way this has been set up is it's been set up to use metadata. So the first thing is the pattern, which determines which particular services are going to use this configuration. And then we can see that various bits are actually included in the data. So requisition port is going to be coming in from the definition of this service. The schema, HTTPS, is coming in from the service. The response, there's various other bits and pieces here. I won't go into all of them. But the point is that there's metadata being used to set this up in the polar configuration.xml. Now, that sets up the type of service we're going to go after. But the actual requisition, which is against each node, is saying that this particular node, Web04 service, we're going to call it, is using the monitor service web post USPTO Q01. Now the key thing is this web post. This web post is going to match against this web post. So that's saying that this particular service is going to basically run all of this configuration. And the data in this configuration, which has been escaped out, is being provided by the metadata that's within this service. So the virtual host is, this particular URL. The path is, their search is generic. And we're looking for this response text in the response. And here we've actually got the payload, and the payload in this case is the JSON that we're going to be sending. You can see that I've escaped the quotes with a quote, because you can't put quotes within a XML definition, so that's been escaped out. But that's basically the query that's been sent. Okay, and this has been sent on a regular basis to the system. So that's basically how this is done. And you can see within OpenNMS, this is the payload that's going out. I can show you the actual configuration for this within OpenNMS. So if I go to provisioning requisitions, within the requisition, this particular one, USPTO, is the one that I'm running. And the Web4 service, look at that. And we can see that's working just against it's not working against, it's working against the default location. The interfaces on this, I've got these services on them. And then the metadata has been created for each of these services here. Okay. So that's how you set up the managing of that particular service. Now, if I go back again to the requisitions, you can see I've set up 4 different nodes. And one node is representing the OpenNMS. One node is representing, is actually running on the Minion Europe, and one node is running on the Minion USA. And that means that these polls are being done from multiple different locations to see that that particular website is actually up. Okay, so that's how this particular service would be monitored using metadata. Let me now go on and look at the trademark search. So this is the trademark search within the USPTO. And again, we have a different type of search going on. So I want to use a basic word search. But if I actually look at this and inspect the queue on it, you can see that the actual data includes this state equals, and then there's a unique string that's given to it. Now, the key point about this site is that that state equals, and then the string there, is actually what the website uses to manage the session for the user. So whenever the session opens, the user is given this state value, and that state value stays with all of the requests that go to the system, and finally goes with the logout, because at the end it's important that you log out at the end of a request. So we have to make a search, we have to use that state, and we have to log out at the end of the search. So in order to look at this particular site, what I'm using is the page sequence monitor, which is a different capability within OpenNMS. And what I'm actually going to do, if I just click on this, you'll see where it takes us to. Oh dear, right, we need to go back. So trademarks, TSS, trademark search, and here we go. And there's the search terms, and we'll get a response back when we get it. Okay, so let me look at how this is actually done. And again, in this case, we're going to be using the page sequence monitor. So we're going after this value, and we're going to get a result back, and we're going to use OpenNMS to search for those patents. So if I just show you what that looks like, submitting the query, and that's the result back. So I need to look for one of these serial numbers coming back, having made that query. Okay, so that's what I need to do. So in my example here, we can see again we've got this service running, and it's running this particular page sequence. So again, if I show you that on OpenNMS, let me just find it. If I go back to OpenNMS, I'll go to the nodes again, and again I'm going to look at this particular node. In this case, I'm going to look at the trade search. You can see here this is the page sequence it's going through. So I'll show you that page sequence in the configuration. So this is the page sequence that it's going through. So the first thing I need to do is I need to get that state equals, and I need to get that value from that state. And so I'm using a regular expression to do that. The regular expression basically finds the href, and then it searches for everything for state. Okay, and it finds that value. So it's first thing I'm doing is doing a get. I'm doing a get against this particular application which is running within the search application, and I'm looking for this response. So obviously here it's not been escaped, but here I've had to escape the less thans and the ands. Okay, but I've basically created a search. Then I've said that I'm going to use value, I'm going to use English TMRK, these are just values I need, and then the state I'm giving it is match group 3, which is the third match group for this. So it's going to find that particular value. So now what I've done is I've created a variable locally called state, which I've extracted from that URL. So that's the first thing I do. I go to the landing page and I get that value. Then the second thing I do is I start a search session page, and I go basically to do a search using that state and using the search string. Okay. So again, you know, I'm basically looking for a search session page, and now I'm going to go to the OpenNMS trademark. So again, I'm getting a search using that, again, search string. So and I'm basically going to be looking for the value coming back. So these are the things I'm putting into the search. Okay, and this obviously OpenNMS comb is what is being sent out as part of the search by the JavaScript in the page, and I'm getting the result back, which is what I expect. Success match. You know, this number, which is one of the patent numbers, needs to be the answer. See, one of the patent numbers here is what I'm looking for back. Okay. So that's the thing. Now I need to log out at the end of the session. So the last thing I do is I post a logout, and again I send it the state, which is telling me what session I'm logging out, and that's what I'm actually sending now. Okay. So again, sending it back, posting the state, and saying logout. Right, so that's the configuration that is needed for the page sequence. And the page sequence has to go into the polar configuration.xml. It's not actually using any metadata, so you're going to have to create a new one of these for every instance you have. Which is slightly less convenient than using the metadata, but it's just the fact you couldn't use metadata for the complexity of this search. Okay, so what it looks like then in OpenNMS, if I go back to the service, is again, this is the result coming back, and obviously it's been out for a little while here, but the rest of it's been okay. So ID's linked with interface, and then it's come back up. Okay, so what I've shown you is two quite different capabilities in OpenNMS, one using the post and one using the page sequence monitor to go through a series of login and logout queries against the page. You can see, however, that you know, this is quite complex to actually build up the polar that you need. So the Selenium monitor makes that process much simpler, and I'll come on to Selenium monitor in a second. Now, the other thing I wanted to say was that in this particular example, I have actually created 4 nodes, and they're just virtual nodes. They're just allowing me to attach IP addresses to a node in OpenNMS. But it's actually the IP addresses that I'm interested in. They may not be on the same server, obviously. They're just IP addresses. But on those IP addresses, I'm hanging these services, these ones which I've defined. I'm obviously looking at DNS as well. It's another example of what we can do with this. We can actually do a DNS lookup against a URL. So I'll just show you that briefly. We're looking at this lookup here, and if it succeeds in looking up and getting a response back from this location, then the DNS is working at that point. Now the point is that this is the default location, but if I go back to the nodes, and pick a different location, this one's running in Europe, then you can see that you know, it's actually running on a different minion, but it's still pulling the same services and same sites. So it's giving you a different view. Now that's one way of setting this up. Okay, have a different node running on different minions and have different services on each of the nodes, and use the metadata to make it easy to do that. And this makes it easy to include all the information you need within a requisition. So if you're using an external system to provision OpenNMS, this can make your life a lot easier. Now, there is obviously another way of doing this, and that is using the distributed monitoring feature of OpenNMS, which actually works in terms of applications. Now, this is a perfectly valid way of doing it. It gives you a different view, and in some ways gives you a more unified view of what's going on. But it doesn't use the metadata that I'd spoken about. So in this case, I have an application, and I'm using a different minion in this case. And I've basically said, again, I've got services that I want as part of that application running on these particular interfaces. And if I show you the topology map, this application then has got underneath it these different services that are running in multiple locations. Okay. If I actually look at the configuration for this within OpenNMS, if I look at manage monitoring locations, we can see that we've got our multiple locations set up here. Then manage applications, and this is the application that I'm looking at. So I'm just looking at USPTO patent in this case, and if I edit that, what we can see is that I have chosen from all the available services that these services are going to be pulled, and then I've chosen what locations those services are going to be pulled from. So from default, which is OpenNMS, and from Minion Canada. Now Minion Canada didn't have any nodes defined on it. So this is the difference. The difference here is that instead of defining a node and assigning it to a minion and assigning services to that node, in this case we're just choosing a set of services from the services that are available, and we're specifying which location those services are going to run on, and then any minions in that location will be used to run that service, and it'll be a round robin between those minions. So it's a different way of setting up the same thing. It gives you a slightly different way of viewing that. We can actually look at the status of the application, and you can see, from default, Minion Canada and default, everything's working fine. You can actually set these both up in parallel to get the view that you want. It basically brings it all together and gives you an overall service availability for those services that you're pulling. Okay, well hopefully that helped explain one way to monitor the USPTO Patent Office from multiple locations. I picked two fairly complex examples, but normally you would just be going to a page, doing a get, and seeing if the text you expect to be on that page would be there. But if you want to check that the searches are working and that things are actually working behind the hood, then the sort of stuff that I've shown you gives you an idea of how you can do that. Now, finally, I wanted us to talk about Selenium. So, Selenium is a open source project that allows you to test websites. And what they have is something called the Selenium IDE, which in this case is an add-on for Firefox. It's also available for Chrome. And I have it installed already on my system. And I'm going to record a new test in a new project. I'm going to call it USPTO. And I'm going to have to give it a base URL. So I'm going to give it this URL. Okay, and I'm going to start recording. Now, what I'm actually doing is I'm recording everything that I go to. So what I'm going to do is I'm going to go to Patent Public Search. I'm going to go to Basic Search, and I'm going to put in my patent number, and I'm going to search for that. And the Selenium ID has recorded all of that. So I'm going to stop the recording now. I hope I'll work out how to do that. Yep, there we go. Name. And you can see that it's recorded all of the steps that are used in that particular request. Okay, so that obviously is a lot easier to actually implement than having to do a lot of manual work to actually get the strings that you need. And the idea of the Selenium ID is that you can actually then rerun those tests. Now, what OpenNMS has done in the past is it has included a Selenium runner within the OpenNMS polling framework, and that meant that you could record a test like this, and then you could take the output from that test. We actually took it in the form of JUnit. So what you can actually do is export this as Java JUnit. So I'm just going to export it as a test to this location. And if I just have a look at it, bring it back into view. That was the test that was generated, okay, and it's basically running a JUnit test. Now, what OpenNMS previously did with its Selenium runner was that you were able to include this test as a Groovy script, and OpenNMS would run it on a repeated basis and take the result. If the test worked, it would work. And you can see here that the recorded options had all been turned into and automatically turned into operations that ran against Selenium. So that's what OpenNMS did do. Now, that particular feature has unfortunately been depreciated due to the libraries that it used no longer being compatible with other libraries in OpenNMS. So it would be a great feature to bring back in some shape or form. But it would be an amount of work to do that, because there's quite a lot of things we need to change within OpenNMS to allow that feature to run. But if we were able to run that feature, then a user could use the Selenium IDE to record what they wanted to do and basically post that recording into OpenNMS, and then OpenNMS would run that test on a repeated basis. And it would be much easier to monitor websites without having to go through the process that I've gone through. So that's Selenium. So just in summary, to tell you what I've basically been telling you all the way through this, what I've shown you is the capabilities OpenNMS has today. It's very capable to monitor websites. You can monitor it from multiple locations, and it does a good job. It's a little bit more complicated to set up the tests because you have to understand the website and you have to know what you're looking for, but it can do a good job. If we reintroduce the Selenium capability, it would make it easier to define the tests, but the basic capability would be the same. It would run the sequence of things that you need to do to get a result from the website, and that would be the test of the website, and it would run it on a repeated basis. So today, OpenNMS, lots of capability to test websites, but in the future with the Selenium IDE integration, then it could do an even easier job of making that possible for people. Thank you very much for listening.